Welcome, Chem 151 students. My name is Jonathan Tullis, and I'm a professor in educational psychology here at the U of A. I'm an expert in the effectiveness of study strategies for learning and improving grades. So today we're going to talk about 4 effective study strategies that will improve grades and your learning. So let's get started with our first one. First study strategy is distributing practice. Distributing practice just means spacing out practice across multiple days and times rather than condensing it together or massing it all in the same day. So here's a visual representation of what we mean. We have Leslie, Marco, and Anne, 3 different students that are all spending 4 hours studying for their Chem 151 test. Leslie spends half an hour at a time and spreads it across multiple days and times. Marco does 1 hour at a time, and Anne does 4 hours right before the test, right? Cramming the night before. What we typically see in our data is that Leslie is likely to earn an A, while Anne is likely to earn a C. More broadly, how we schedule our study time matters. It's not just how much total study time we put in, but really how we are scheduling it that's going to affect how well we learn. Here's an example of that. We've got 116 University of South Florida students that are learning permutations or this math operation. We've got a group that has their practice spaced out into 2 different days. They do the first 5 problems in session 1. They wait a week and do the next 5 problems. And then they've got the test either 1 or 4 weeks later. We've got a group that is massing or cramming it all together in the same day before they take their test. And what we find is that our spacers, or people that spread their study across 2 days, remember much more, 64%, compared to the masters that do it all at once. In other words, we're doubling how much we remember. We've got another example here with undergrads studying meteorology. They're studying things like what's a supercell and what is air pressure and when does lightning strike. We've got a group that spaced their practice across 8 days. So practice A, wait 8 days, and then practice B, versus a group that does them back to back. And then we have our test 35 days later. What we find is the group that's spaced out their practice more remembers more than those that do it back to back. Again, cramming doesn't work. We got to distribute or space our practice out. All right, so why is distributing practice so useful? Lots of good reasons here. Long-term learning requires us to change our neural connections. It requires us to create or strengthen new connections in our brain, right? This is called long-term potentiation. So here's an example of a synapse between 2 neurons. We've got one neuron communicating to another neuron, sending their chemicals across that synapse, producing this chemical electrical signal that gets produced. That's before we get trained. Then after we get trained, what happens is this receiving synapse develops a lot more receptors, 5 receptors compared to 3. And the neuron that's sending that signal is sending much more neurotransmitters into that synapse. And finally, what that translates to is we get a bigger signal that gets sent. Okay, this is called long-term potentiation. We are changing or strengthening those neural connections, which is required for long-term learning. This happens really slowly, similarly to how building muscle takes time. Cramming or studying it all at once is not going to produce the long-term potentiation or changes in these neural connections that we need. Another reason is that when we learn and then we go to sleep, what happens during sleep is we replay a lot of those memories. And replaying those memories during sleep leads to consolidation, which allows us to retrieve it better. So what exactly do we mean by consolidation? Well, when we first form a memory, it's stored in the hippocampus. There's connections among the neurons there. What happens during consolidation or sleep or waiting over time is that it gets transformed from being in the hippocampus up to in the cortex. So it's no longer stored necessarily in the hippocampus, but it's stored in a different part of the brain. It gets transferred and transformed into that cortex. Here's another representation where initially it's stored in the blue hippocampus here with connections to the cortex. But across consolidation, it's no longer dependent on the hippocampus. It's more integrated into our knowledge. It's more stable in our cortex. And that's going to lead to more stable, more generalizable knowledge that we can use in the future. All right, great. So what does that mean? How can we use this to support our learning? How do we use distributed practice? Well, cramming is really bad, right? Waiting the last minute before the exam, the night before, it's not going to allow us to form those long-term memories. So cramming is bad. We need to spread our study throughout the semester. And that means we probably need to schedule to study a little bit every day and stick to that schedule. Spreading out or distributing practice is really useful for creating those long-term lasting memories.